Hello dear students. In this video, we will see what is the relation between two-dimensional array and pointer. Now as you see, I have declared a two-dimensional array of 4 rows and 2 columns. And I have drawn some diagrams, but what I want all of you to do first is that just please revise the concept of one-dimensional array that we saw in the earlier videos. Have patience and go through this first. Now, note this declaration. Imagine that I have declared an array A of 5 elements. Then in the memory of the machine, these 5 cells or 5 elements are stored in continuous locations as a sequence of bytes. If you imagine that this array of 5 elements starts at location 100, and just imagine that each integer consumes 2 bytes. Imagine this. Then the 0th location of this array is going to consume 2 bytes. So 100, 101, these 2 sequential bytes will be eaten up by the 0th element. Similarly, 102, 103 for first element or element 1 and so on. This we had seen in earlier videos. Now some notational conventions. You just go through. You know that name of the array A. See, A is the name of the array. Name of the array gives base address. That is 100 in our case. So if you write in your program A, just A, you get that base address of the array. Some more notations that we saw in the previous videos is that suppose you want the address of this 0th element. Just say, suppose you want where is this 0th element, that is 10, stored. What is the address of this? Then one way is just write ampersand symbol, which is address operator, and then say whose address you want. You want address of A0. But the same thing can be written as A plus 0. Even A plus 0 will give address of 0th element. Because you know A itself is 100. This is same as 100 plus 0. Correct? Which is 100. And this 100 indeed is the address of the 0th element. Just check. This 0th element is surely stored at the 100th location. But then what is ampersand A1? We want address of A1. That means we want address of this element number 1, which is 102. So if you write ampersand and whose address you want, A1, you will get 102. But writing this is same as A plus 1. Now you know that A is 100. A is 100, the base address. Name of the array itself is the base address and you are adding 1 to it. But please try to understand A is pointer to an integer array. So it is basically an integer pointer. And if you increment this integer pointer by 1, then it will get incremented by 2 because every integer is consuming 2 bytes. Okay. So the result of this won't be 101, it will be 102. And this indeed is the address of first element, that is A1. So in general, if you want address of any ith element, just check this. If you want address of ith element, then you write AND AI. But this is same as A plus I. I hope you are revising the facts with me before we learn 2D array. Now what if I remove that AND symbol and suppose I want value of A0? That means I want to know what is stored at the 0th location. Till now I was just searching for address. What if I want to know what is stored over here at A0? Then programmer may write A square bracket 0. This will give value of A0. But this is same as asterisk A plus 0. Why? Because if you solve this bracket, you will get 100 plus 0 because A is 100. So this is same as asterisk 100 plus 0, which is same as asterisk 100. But you know 100 is the base address. And you are then using the asterisk symbol, so you will get value stored at that address. And what is the value stored at address 100? It is 10. So this value is going to be 10. And it is indeed the value of A0. But then what is A1? A1 means value of A1. That is 20. But the other way of writing it is asterisk A plus 1. Because you know that A is 100 and you are adding 1 to it. Correct? And you are doing an asterisk before it. But 100 plus 1 is going to be 102 because we are talking about integer pointer. And every integer we have assumed that it consumes 2 bytes. So incrementing an integer pointer by 1 will increment it by 2. So this is same as value at the address 102, which is same as 20. So indeed, in general, if you say what is AI, imagine you're asking for AI. What is the value of AI? It is same as asterisk A plus I. One more word here. Have patience before we go to 2D array. In C language, whenever you write any variable followed by square bracket followed by some subscript, if you write such a notation, then it is actually taken by C compiler as asterisk Z plus I. Because you are now checking value, you are using value at ith location. But if you write and Zi, imagine address of Zi, this is taken as Z plus I. So whatever is written outside the square bracket and whatever is written inside the square bracket is simply added first. Simply added. And if you are looking for value as you are saying here for Zi, then it is preceded with asterisk. This will give you the value. But if you are writing Z square bracket I, then Z is simply added with I again. But you are asking for address and this itself is the address. So there is no asterisk before it. So keeping these fundamentals in your mind, let's go to the first page where we are looking for two-dimensional array and pointer. Now look at this declaration. We have an array of 4 rows and 2 columns. This is the way how we read it. So the 4 rows I have shown here is 0, 1, 2, 3. These are the row numbers. And just check there are 2 columns. So the columns are also labeled as 0, 1. Now this is the usual way in which we draw a two-dimensional array on paper. And we have assumed here that some values are stored here. Although I agree I have not shown how to store those values. But just imagine these values are stored. Now it's usual to draw the matrix like this in the form of rows and columns. But in the memory of the machine, this two-dimensional array is stored as a sequence of bytes. Please understand that in the memory there is nothing called row and column, or there is nothing called rectangular structure like this. So all values are stored indeed one after the other. And what you have to understand from this matrix, what you have to understand or a two-dimensional array is, this two-dimensional array is in fact four different one-dimensional arrays of 2 elements each. 2 elements each. I mean, you can just check. This indeed is a separate one-dimensional array. This is another one-dimensional array. This is another one, and this is the final one. So how many one-dimensional arrays have you created? 4, because we have given first subscript as 4. And how many elements is each one-dimensional array containing? 2 elements, because we have said that each one-dimensional array will contain 2 elements, and that's how we got two-dimensional array. So if you show this representation in the memory, they are in sequence of bytes. if you imagine that this entire two-dimensional array is stored from location 400, imagine this, and also imagine every integer consumes 2 bytes. Then first 10, this 10, first 10, first value is going to consume 400, 401, 2 bytes. So the next location is going to be 402, 403, 20. Now you note this 10, 20 is in fact the values of 0th row, 10 and 20. Observe this. And they are sequentially stored from 400, 401, 402, 403. Okay. Now what is then stored after that? At 404, immediate location, the next row, values of next row have been stored. Values of next row are 30, 40. So you can just see that 404 and 405 will consume 30 or will store 30, and 406 and 407 will store 40. And then you can say that between 404 and 407, values of the first row have been stored. Correct? Similarly, 408, 409 will store 50, 410, 411 will store 60. This, that is between 408 and 411, values of second row have been stored, and from 412 to 413, 414, 415, values of row 3 are stored. So this is how a 2D array looks like in the memory, not like a matrix. Okay. Now one more thing. This entire block, this block which I am marking, what is this? This is values of row 0, 10 and 20. In fact, this represents row 0. Okay. Then, in fact, if this values 10 and 20, that is 400 to 403, represents A0, then this entire segment can be known as A0. Just check. It is a 2D array. It's a 2D array. But we are writing only a single subscript over here. Similarly, this portion, which is storing 30, 40, is A1. This portion, which is storing 50, 60, is A2. And final portion, which is storing 70, 80, is A3. What that means is, this A0 gives address. Just check my words. If I write A0, that is using single subscript. If I write A0, then I will get address of where does 0th row begin. And 0th row begins at 400. Now, if I write A1 in my program, A with a single subscript 1, then we will get address of where does row 1 begin. That will be 404. Similarly, A2 will be address of row 2, which is 408. Base address, I am saying, base address. Where does that row begin? I am talking about. And A3 will give us base address of row 3. So some notations, you just check. I'm just writing in the algorithmic fashion, okay? I'm not writing printf and all that formats and all that. First thing, what will happen if I write print A0? This gives base address of row 0. So what will happen if I write print A1? This will give base address of row 1. As you see in our example, base address of row 0 is 400 and base address of row 1 is 404. So in general, if I write print AI, where I is some subscript, then this will give base address of row I. Some row I am checking where does that row begin in the memory. Now, I want all of you to remember what I said about one-dimensional array. The last point I made in the beginning of this lecture is that whenever you write any name followed by square bracket, inside that when you write some subscript, then this is simply replaced by compiler with asterisk followed by z plus I. Why asterisk? Because we haven't asked for address. Anything written like this is simply replaced like this. So coming back to our page, you tell me, instead of print AI, just check this. If we would have written print, instead of A0, I'm sorry, if we would have written print A plus 0, you would say, what is all this notation? Please try to understand, A0 and asterisk A plus 0 are same. That means this will also give base address of row 0, which is 400. See, both these notations are same. Okay. So what will happen if I write print for my 2D array? For my 2D array, if I write print, let's say, here we go, print A1, you know this will be 404, because you know by now that this is A0, this is called A0, this is A1, A2, this much portion is A2, and finally this is the last row, that means A3, and these names give the base address. So this will be base address, as we saw, base address of row 1, which is same as 404. But what if you write print asterisk A plus 1? Please try to understand, both these notations are same. So this is also going to give us address of row 1, which is 404. All right. Now, if we have understood this much, now let's see what will this do. Now we are really digging into this. Suppose I write A, just check this. If I write A 1 2, let's say 1 2. This means I want value, surely, because I have not written AND before this. I want value stored in first row and second column. Now imagine that the values stored are 10, 20, 30, 40, 50, 60, 70, 80. Imagine this. What is A12? It is value stored in first row. Remember, first row starts from 404, correct? And sorry, this is not 2, this is 1, A11, sorry. So A11 means, first of all, we will have to look into the row 1, and row 1 starts at 404, okay? From this element which I am marking, and in that I want first column. Now first column is indeed storing 40, because you all know that this matrix was shown as 10, 20, 30, 40, 50, 60 and 70, 80. 70, 80. So what we are talking about is, this is 0, 1, 2, 3, and the columns are 0, 1. We are talking about first row and first column, so that is 40, this element. So you know this is going to give value 40. But this is same as saying, now we are really challenging ourselves here. This is same as saying asterisk, just check this, asterisk A plus 1 and the whole asterisk. Just dig into this. Now what is this asterisk A plus 1? First of all, solve it part by part, you will understand. What is this? Asterisk A plus 1. First solve this portion. Oh, this is same as this one. Asterisk A plus 1 is same as base address of row 1. Just check, we have already written that. So this is going to give 404, because that's the base address of row 1. And we are adding 1 to it. Still we are on with this outer bracket. Now you are adding 1 to 404, but listen, you are adding 1 to an integer pointer. That means, and if we assume every integer consumes 2 bytes, then this value is not going to be 405, but it's going to be 406. So we have already solved this asterisk. This gave us 400. We have added 1 and the outer asterisk is still remaining. So this gives us asterisk 406. And just note, 406 is indeed the address of 40. So at that address, what is the value stored? 40, and we get that value. What that means is writing A11 is same as writing this notation, which I am right now underlining. Okay, let's see it again. What if you want this value? Just check this. I say print A 21, let's say 21. Now, which is this element 21? Let's peep in the matrix. Second row and first column, which means it is 60. Now, how do you get this value? Basically is, you first get the base address of row 2. Where does this row begin in the memory? And then jump by one integer, because you don't want immediately this integer. So, but then how do you get the base address of row 2? By the way, you have seen that this is 60. This is 60. Now have a look at this notation again. I first want address of row 2 because I want to go beginning of row 2. So I can write asterisk a plus 2. Asterisk a plus 2. This will give address of second row. But then I add 1 to that address because I want to jump by one value. And once I do this, I get the address of the value that I want. And then finally I put asterisk. This will also give me 60. What you have to understand here is that if I write, I'm erasing this slate. If I write a notation such as Aij, where A is the name of two-dimensional array, then what I am trying to find out, I am trying to find out what is the value stored in the ith row and jth column. Some ith row, before this also there are many rows maybe, and after this also there are many rows. But this is ith row and some column j. I want to know. Let's say this is column j I am talking about. And this value I want to know. What is it? I want to get this value. Then first of all, you will have to jump to the address of the ith row. But how do you get address of the ith row? You can get address of the ith row as asterisk a plus I. Why? Because you know that simply writing a double dimension array with single subscript I will always give you the base address of the ith row. Check the diagram that we have seen earlier. Name of the array with single subscript gives the base address. Name of the array with single subscript gives us the base address of that row, isn't it? So this AI gives base address of the ith row. This can be written as asterisk a plus I because these notations are same. But we want jth column. That means we want to go ahead by j integers. So you know that if I add j to this, then I will reach that many bytes ahead and I will reach the jth integer. By the way, if I write this notation, then I will get the address of this location, which I am right now marking. But I don't want address, I want a value. So I will give asterisk before this. So Aij can be written as or is equivalent to asterisk followed by asterisk a plus I plus j. Okay. But this is also equivalent to asterisk ai plus j. Oh, this is a easier notation because ai is same as asterisk a plus I. So this first notation aij, this second notation and third notation, all three mean the same. All three have the same significance or the same value. Okay. So this is how two-dimensional arrays can be seen, and they are related to pointers because name of the array followed by single subscript itself is the pointer to the base address of 0th row, base address of first row, base address of second row, and base address of third row. And then using these base addresses, you can jump within that row forward by any number of integers and get that value. So that's it for this video. In the next videos, we will see more examples and more exercises on 2D array and pointers. Thank you very much.